23 car salespeople were sampled to see how many cars they sold in a month. The following data was obtained. And then we have the data in number of months. Construct a 98% confidence interval for the mean number of cars sold per month by the population of car salespeople. So we're constructing a confidence interval, which is what we've been doing in this chapter, and we're constructing it for the mean. But unlike in the past when we constructed a confidence interval for the mean, in this case we are not told what the population standard deviation is. So because we don't have the population standard deviation, in addition to the sample mean x bar to estimate our population mean, we will need to use our sample standard deviation as an estimate for our population standard deviation. Okay, so our first step here is going to be to calculate the sample mean and the sample standard deviation. So let's grab our data here. Okay, and I'm going to start by throwing it in here. Paste. Okay, I've got my data. Okay, and I ran it, so it's all set. It's stored in the variable. So first step, we need to find that mean x bar. Okay, so to do that, we will need our sample size. Okay, now you could also just go back to the problem. We are told that it's 23, so n better be 23. So you could check that if you want. Once we have that, though, we are ready to find a mean. So mean is just the sum of all those values in our list of values divided by how many there are. Oops. And let's print that out. Okay, there it is. That's our mean. So on average, our sample average is 28.26 cars sold a month. Okay, so let's copy that. That's what's going in our first box. Okay, now with that same data, we're going to have to calculate the sample standard deviation. So let me get a new code cell for that. So sample standard deviation is going to be, and let me remind you of the formula because it's kind of a complicated formula. So sample standard deviation is the square root of the sum of all our data values minus the sample mean squared. And then I divide all that by 1 less than the sample size because it's a sample standard deviation. Okay, so we want to do this. We want to do this using our notebook. We want to calculate that. So if we look at this, our numerator is where we're adding up those values. So sum x minus x bar squared. Okay, so that's going to be our numerator. Notice we're taking the difference of our x values here. Okay, our list of values. For each value, we're subtracting our x bar, which is our sample mean. And then we take that difference and we square it for each and every x, for each and every data point here. And then once we do all that, we're going to add it all up. And we're going to divide by n minus 1. And remember, n is our sample size. We already found that. Okay. And you want to make sure you put that in parentheses, or else it'll divide by just n. We want the whole n minus 1. We want to divide by that whole thing. Okay. All right. So we've done everything under the root. Now we actually need to take that square root. So I'm going to go back to the beginning and SQRT, and then I'm going to put all of that in parentheses, so I'm taking the square root of all of it. Okay, and that's going to be our sample standard deviation. So let's run that, and I put an extra S here, so we'll print out. There it is. That's our sample standard deviation. Okay, so now that we have that, we want to calculate alpha over 2. which is exactly the same calculation as what we have been doing for calculating confidence interval for a proportion or for mean where we know this population standard deviation. It's the same exact process for that alpha over 2. So just to remind you, the idea here is we want a confidence interval about the sample mean. And in this case, in this particular example, we want a 98% confidence interval. 98% confidence interval. So that means we want 98% of our area to be here. So we want to be 98% sure that we're within this interval between here and here. Okay? Our alpha is what's left over. Okay? So what's in the tails? That's our alpha. And since I have 2 tails, each tail will have half of that. So this tail will have the alpha over 2 area. This tail has alpha over 2 area. Okay? So since we're dealing with a probability distribution, we know the total area is 1. And then we want to subtract off the blue bit. That's what we don't want in the tails. Okay, so 98%, that's 0.98. And so that leaves me with 0.02. Okay, and then we just want half of that for our alpha over 2. Okay, and if you want to, you could always do that in the notebook. So the alpha, the bit that's left of the tails, is 1.00 minus our confidence level. And what we really want is alpha over 2, which is just half of alpha. So let's print that out. And so in our case, it's 0.01. So what that's telling us is we have 0.01 or 1% of the area in this tail, and 0.01 or 1% of the area in this tail. Okay? All right, next we need to find T alpha over 2. Since we do not know the population standard deviation, we are not using a normal distribution. We're not finding a z-score. We're approximating that population standard deviation with our sample standard deviation. Because we have to approximate it, we have to use a slightly less accurate distribution to kind of offset the fact that our standard deviation isn't the population standard deviation. So we use a t distribution, students' t distribution. Other than that, the way we find T alpha over 2 is just about the same. Okay, we want, and let me get a little bit more room here. Okay. So we kind of have the same picture over here. This was our 98%. Okay, and we discovered we have 1% or 0.01 in each tail. That's the area left in each tail. Okay, now this is a t distribution, and we want T alpha over 2 so that the area greater than above T alpha over 2, the area left under the curve above T alpha over 2 is 0.01. Okay, so in this case, T alpha over 2 is T sub 0.01. That means the t-score with area to its right of 0.01. So we're going to use our notebook to calculate that. So we want to find the t-score, and we're given a probability. So we're going to use the qt function and then plug in the p, plug in the probability. That probability is our alpha over 2. So you could either type in 0.01, or you could actually write alpha over 2. I tend to like the variables. It helps me so I don't have to copy and paste the numbers if I find I make a mistake later. Okay. Now, a difference from the t-distribution, from the normal distribution, is that the t-distribution requires that degrees of freedom. Okay. The degrees of freedom will always be 1 less than our sample size. So in our case, we have 23 car salespeople. So we have 23 data points. So our sample size is 22, 1 less than 23. You could also type in n minus 1 because n is also the sample size, and so we're just going 1 less than that. Okay? And then we need to decide if we want lower tail. Is this going to be true or false? So if we look at our picture, we want T alpha over 2 right here. Right here. So that is the alpha over 2 is above it, right? That area is in the upper tail, not the lower tail. So we're going to set lower tail equal to false. We're going to run that. Okay, and there it is. That's our t-score. In fact, I'm going to store it in a t variable, print it out, and that way I'll have it for easy reference later on. So that is my t alpha over 2. So let's copy that, paste it in the text box. Okay. Okay, we're ready for our margin of error. So our margin of error, the formula for margin of error. So when the population standard deviation is known, and remember for this case it's not, okay? But if the population standard deviation is known, the margin of error is our z-score, or z alpha over 2, times our population standard deviation sigma over the square root of n. And remember this bit here, that's the standard error, or the standard deviation of our distribution of sample means from the central limit theorem. Okay, so we're just saying how many standard distributions are we from the mean in terms of our distribution of sample means. But of course, we don't know the population standard deviation in this example. But the formula, once you understand what all the pieces mean, it's almost the same. So we're using T alpha over 2, and remember we're using a T distribution. We're using a T distribution instead of a normal distribution with its z-scores because we don't know the population standard deviation, so we have to use a slightly less precise distribution. And instead of the population standard deviation, we have to estimate that quantity with our sample standard deviation S. Okay, so it looks almost the same. It's the same idea if you know what those pieces mean. But this is the formula we're going to use right here because we do not know our population standard deviation. So let's plug in according to that formula. So our error is going to be our t-score, our t alpha over 2. And so you could either copy and paste that number in, or if you store it in a variable like I did, you could just type in the variable. So I'm just typing in the t, and I'm going to multiply that by my sample standard deviation. And again, you could copy the 2.700 here, or if you store it in a variable, just type in the variable, divided by square root of the sample size. And again, the sample size we are told in the problem, it's 23, so you could either type in 23, or if you stored it in a variable, just type in the name of the variable, so n in this case. Okay, and then I'm going to type E one more time so I can see what it actually is. So my margin of error is 1.412. So let's copy that whole thing, paste it in. Okay. Okay, we're almost done. Now that we have our margin of error, we we want to construct our confidence interval. So going back here, we want to find this guy and this guy right here. So to find those guys, we just need to realize that our margin of error is telling us how far we need to go from that sample mean x bar. So this is going to be x bar plus e. It's going to be x bar minus e. Okay, and that's going to give me the edges right here of my confidence interval. So I'd be 98% confidence in this case that we are between this value and this value, that the true population mean is between these two values. Okay, so all I need to do is take my sample mean, which I stored in the x bar variable. I want to subtract my margin of error, and I want to take my point estimate, my sample mean, and I want to add my margin of error. And that's going to give me my two boundaries. So there's my two values. Let's copy and paste each of them. So lower number in the first box in this last part, and then bigger number in the second box. So we are 98% confident that on average, car salespeople sell between 26.85 cars and 29.67 cars per month. Okay, that on average. Okay, so let's submit it, and we have it.